Hello everybody. Today we are going to see Unit 3 of MCS 014, and Unit 3 is about process of system development. What comes under process of system development? Here are the index you can see, but we will straight jump to the introduction. Information systems analysis and design is a complex and stimulating process that is used to develop and maintain computer based information systems. The analysis and design of information systems are driven from an organizational point of view. An organization might consist of whole enterprise, specific departments, or individual work groups. Information systems analysis and design is therefore an organizational improvement process. Systems are built and rebuilt, enhanced for organizational benefits. Benefits result by adding value during the process of creating, producing, and supporting the organization's services and products. Thus, information systems analysis and design is based on the understanding of objectives, structure, and processes of organization and the knowledge about the application of information technology for this purpose. Most organizations find it beneficial to use standard sets of steps called a systems development methodology to develop and support their information systems is like many processes. The development of information systems often follows a life cycle called systems development life cycle. For example, a product follows a life cycle when it is created, tested, and introduced in the market. Its sale increases and goes to peak point, and after that it declines and a new product or next version of the existing product is introduced in the market to replace it. SDLC is a common methodology for systems development in many organizations, consisting of various phases that mark the progress of system analysis and design effort. Now come objectives. After going through this unit, you would be able to define information systems analysis and design, describe the information systems development life cycle, and list alternatives to SDLC and compare the advantages and disadvantages of SDLC to its alternatives. Systems development life cycle. Most organizations find it beneficial to use a set of steps called a systems development methodology to develop and support their information system. Like many processes, the development of information system often follows a life cycle. The system development life cycle SDLC is a common methodology for system development in many organizations, featuring various phases that mark the progress of the system analysis and design effort. Although any life cycle appears at first glance to be a sequentially ordered set of phases, but actually it is not. The specific steps and the sequence are meant to be adapted as required for a project, consistent with management approach. For example, in any given SDLC phase, the project can return to an earlier phase if necessary. If a commercial product does not perform well just after its introduction, It may be temporarily removed from the market and improved before being reintroduced. In the system development life cycle, it is also possible to complete some activities in one phase in parallel with some other activities of another phase. Sometimes life cycle is iterative, that is, phases are repeated as required until a satisfactory and acceptable system is found. Such an iterative approach is special characteristic of rapid application development methods such as prototyping. Some people consider life cycle to be spiral, in which we constantly cycle through the phases at different levels of detail. The life cycle can also be thought of a circular process in which the end of the useful life of one system leads to the beginning of another project that will develop a new version or replace an existing system altogether. However, the system development life cycle used in an organization is an orderly set of activities conducted and planned for each development project. The skills of a system analyst are required to be applied to the entire life cycle. Project initiation and planning. Then comes project identification, analysis, logical design, physical design, implementation, maintenance. So it's figure 3.1 phases of system development life cycle. So this is the phases of system development life cycle. So this is the diagram. Now comes every custom software producer will have its own specific detailed life cycle or system development methodology. Even if a particular methodology does not work like life cycle, does not look like cycle, you will discover that many of SDLC steps are performed. SDLC techniques are tools and tools are used. In order to make this unit generic, we follow a rather general life cycle model. This model resembles a staircase with arrows connecting each step to the step before and to the step after it. This representation of the system development life cycle SDLC is sometimes referred to as the waterfall model. We use this SDLC as one example of methodology, but more as a way to arrange the steps of systems analysis and design. Each phase has specific outputs and deliverables that feed important information to other phases. At the end of each phase, system development project reaches a milestone, and as deliverables are produced, parties outside the project team often review them. Phases of SDLC. SDLC consists of mainly 7 steps. These are, so let's see how long this unit is. Okay, we will complete till check your progress 1. So here were we. SDLC consists of mainly 7 steps. These are project identification and selection, project initiation and planning, analysis, logical design, physical design, implementation, testing. Project identification and selection. The first phase in the SDLC is called project identification and selection. In this phase, the user identifies the need for a new or improved system. In large organizations, this identification may be part of a systems planning process. Information requirements of the organization as a whole are examined, and projects to meet these requirements are proactively identified. The organization's information system requirements may result from requests to deal with problem in current systems procedures, from the desire to perform additional tasks, or from the realization that information technology could be used to capitalize on an existing opportunity. These needs can then be prioritized and translated into a plan for the information system department, including a schedule for developing new major systems. In smaller organizations, determination of which system to develop may be affected by user requests submitted as the need for new or enhanced systems arises, as well as from a formal information planning process. In either case, during project identification and selection, an organization determines whether or not resources should be devoted to the development or enhancement of each information system under consideration. The outcome of the project identification and selection process is a determination of which systems development project should be taken by the organization, at least in terms of an initial study. Now comes the um, project initiation and planning. The second phase is project initiation and planning. The problems that are identified should be investigated, and a decision to implement the information system or not for the organization should be taken. A critical step at this point is determining the scope of the proposed system. The project leader and initial team of system analysts also produce a specific plan for the proposed project, which the team will follow using the remaining SDLC steps. Now, this baseline project plan customizes the standardized SDLC and specifies the time and resources needed for its execution. The formal definition of a project is based on the likelihood that the organization's information system department is able to develop a system that will solve the problem or use the opportunity and determine whether the cost of developing the system outweighed the benefits it could provide. The final presentation with the subsequent project phases is usually made by the project leader and other team members to someone in management or to a special management committee with the job of deciding which project the organization will undertake. Analysis is the next phase. During this phase, the analysis has several subphases. The first is the requirement determination. In this subphase, analysts work with users to determine the expectations of users from the proposed system. This subphase usually involves a careful study of current systems, manual or computerized, that may be replaced or enhanced as part of this project. Next, the requirements are studied and structured in accordance with the interrelationships and uh, eliminate sorry eliminate what's it eliminate any redundancies. Third alternative, initial design is generated to match the requirements. Then these alternatives are compared to determine which alternative best meets the requirement in terms of cost and labor to commit to development process. In this phase, feasibility study of the proposed system is also performed. Various types of feasibilities are technical feasibility, economic feasibility, behavioral feasibility, operational feasibility, legal feasibility, time feasibility. If the proposed system is not feasible to develop, it is rejected at this very step. The output of the analysis phase is a description of, but not a detailed design for, the alternative solution recommended by the analysis team. Once the recommendation is accepted by those with funding authority, you can begin to make plans to acquire any hardware and system software necessary to build or operate the system proposed. System design. After analysis phase is complete, design of the system begins. The design consists of logical and physical design of the system. The fourth and fifth phases are devoted to design of the new and enhanced system. During design, you and the other analysts convert the description of the recommended alternative solution into logical and then physical system specifications. You must design all aspects of the system from input and output screens to reports, databases, and computer processes. Design occurs in two phases, which is logical design and physical design. Logical design. Logical design is not tied to any specific hardware and system software platform. Theoretically, the system could be implemented on any hardware and system software. The idea is to make sure that the system functions are intended. Logical design concentrates on the business aspects of the system. Physical design. In physical design, the logical design is turned into physical or technical specifications. For example, you must convert diagrams that map the origin, flow, and processing of data in a system into structured systems design that can then be broken down into smaller and smaller units known as modules for conversion to instruction written in a programming language. You design various parts of the system to perform the physical operations necessary to facilitate data capture, processing, and information output. During the physical design, the analyst team decides the programming language in which the computer instructions will be written in, which database system and file structure will be used for the data, the platform that will be used, and the network environment used, which the system will be run. These decisions finalize the hardware and software plans initiated at the end of the analysis phase. Now, proceedings can be made with respect to acquisition of any technology not already present in the organization. The final product of the decision phase is the physical system specification in a form ready to be turned to programmers and other system builders for construction. The physical system specifications are turned over to programmers as the first part of the implementation phase. So here we come to the end, and the check your progress will answers will be available in the description. Till then, bye.